Cindy, you all right there?
All right, to turn it on, right here is the on-off switch. Over here, gotta remember where to turn it on. When you turn it on, it runs it through its little self-test. Back away.
Phone broke. Oh.
Is it working? Is it working?
That's good. Yeah,
Oh, okay.
He's making fun of me because my screen cracked.
Oh, all right. And then it comes, so it runs through a little test, and then it comes up to this screen right here. And this ventilator in particular needs a flow sensor. So you have to have this. Might as well have a little.
There's 2 views, don't worry.
Oh, great. I'm going to be all over the YouTube.
Popular. You got a million hits in the last video.
Oh, I doubt it. Okay, flow sensor is you must have the flow sensor for this ventilator or it will not work. So what this does is it measures up here the actual flow being delivered, and when we calibrate it, it's going to calibrate this flow sensor. There's little plastic flaps in here that actually open, and when the flow goes through, it can sense how much flow is going through by how fast it does that. So that goes on here. When it's hooked up to a patient, the blue needs to be facing the patient. Blue and clear on the end of our hoses, folks. And if you look down here, this is blue. There's a little blue ring around it, and this one is clear, so it's easy to know which one goes where. So you're just going to hook them like so. One goes there, and one goes there, like that. And then our lung will go right onto here. When you have to have a 15 millimeter adapter to hook up from, this will not hook directly onto an ET tube. Can you hand me that ET tube over there? Won't work because they're the same size. So we're gonna get a 15 millimeter adapter when I hook it up to the test lung to hook it up. Oh, no, we're not. There's one right here. So, humidifier. We have our filter on the inspiratory side. See here, we got an arrow pointing out. Remember I told you every ventilator helps you out by knowing which one's inspiratory and which one's expiratory. So pointing out goes to our patient. So we hook that there with our filter to one side of our humidifier. Inspiratory is always going to go to the humidifier, and then the inspiratory line going to our patient, and then expiratory into our exhalation valve. This one has an external exhalation valve. This twists and comes out and has the diaphragm in here. You must be aware of this with this ventilator because if this is in wrong or it sticks or anything like that, it won't work because it won't cycle in between inhalation and exhalation. Because it has a little magnet in it. It literally goes up like that during inspiration and goes down during exhalation to allow that to go on. Every ventilator has an exhalation valve. It's just a matter if you can see it on the outside or whether it's on the inside. That's the only way. So this little red diaphragm says down on one side. That means it goes down in here so that the little magnet is face up. And then we'll just put that right back in here. And it goes in and then twists when it's locked into place. Okay, so on the front screen, we have standard setup, adult, pediatric, or infant, so you can go into whichever one you want. Of course, we're going to be using adult. Last setup, if you want to go see what was done last or use the settings from the last setup, you can push that, or start. Remember, we all do it, and you all laugh at me, but you are all going to try to do this. It's not touch screen, no matter how much we want it to be. So
The next one will be.
It looks like a touch screen.
I know, and believe me, my brain thinks it's a touch screen, so, but it's not. So you got to press the button when the orange, wherever the orange is where the scroller is right now, and so we're going to push that to do start, and we'll come on over to this screen here. It's telling us that a flow sensor cal is needed. The calibration for this ventilator is not as fancy schmancy as all the other ones. Some of it we do the old-fashioned way. We have this little card that says pre-operational check on it. And I'm sorry, I can't resist. It tells us that this must be performed before we put it on a patient. So you know you have the servo. Oh, I don't think the oxygen and the air are on. I'll get them in a minute. We have the servo and the, can you get a test lung, please? One of you guys? the servo and the PB and everybody has their thing, their own little calibration that it takes you right through. This one we do the old-fashioned way. I'm not going to do them all, but you guys will need to go through this. It's going to tell you to turn it on, come up to the screen where it says self-test, and then put standard setup so that the ventilator starts. And then, thank you. And then it's going to tell us to unhook the oxygen. So when we do that, we'll get an alarm that tells us that the oxygen supply failed. So you know the other ventilators ran you through an actual step through the screen. This one is just a manual way to do it, and it takes a minute, but in a minute we'll get that the oxygen supply failed. And so you'll just keep going through that. So you need to do this, because when you do your testing in that, I'm not going to make you go through every single stage on this pre-operational check, but you need to be able to tell me that this is part of your calibration. In this calibration, there is also the flow sensor test and the tightness test, which I'm going to show you how to do. So here we see our oxygen supply failed. Did you guys see it? So once you get that, you can put it back in. I can't do that at that angle with that hand. Thank you. And so that'll go away. And then you'll do the same thing with the air. And then you check like the high pressure. So it'll have you kink the tubing so you confirm that the high pressure goes off. Things like that. Part of this calibration is doing a flow sensor test and a tightness test to get to that section. And this is either usually hanging by one of those little ring things on the back of the ventilator. To get to the calibrations, you go to the mode screen, and then you scroll down to calibration. Right there. And then so when it says orange, remember, hit the button to confirm. It will take us over to that screen. We have the flow sensor test and the tightness test. We do not do an O2 cell test unless the ventilator tells us we have to. So first thing we're going to do is the flow sensor, and it's checking this to make sure that it's good, that it works, and that it calibrates for how much flow. You're going to see when we do this that it actually puts a whole bunch of flow through there, and you can see that the sensor actually going like that to test it. So, and it's also telling us it wants us to do a flow sensor cal. Sometimes it will do that just while you're ventilating, and you'll need to stop and calibrate your flow sensor. So again, we're orange, we hit it. All the calibration comes in blue at the bottom, so you need to pay attention to the blue wording that comes up. It tells you exactly what to do, just like the other ventilators, but sometimes you're going to have other colors coming up. You need the blue. So it's telling us to disconnect our patient, so that's what I'm going to do. It will automatically sense it. Now it wants me to turn the flow sensor. When it asks to turn the flow sensor, you're literally taking it and turning it like that. So now it's going to be with upside down with the blue the other way. Okay? And then it knows I did that. It can sense it, so it's going to say calibration in progress. And when you guys do this, if you watch your flow sensor, you'll see that it's increasing the flow, and it's actually sensing that by that sensor that's in there, and it can sense the changes by the factors. Okay, now it tells us to turn the flow sensor. So remember, literally, we're going to take it and turn it back around the other way, like that. So now the blue's back on top. It knows we did it, so it's going to continue to do the calibration. So let's move it on now. And you'll see it's changing. If you watch your waveforms while this is happening, you'll actually see the changes in it. Why didn't it tell me? Did it say it was complete? Let's do it again. Because normally I'll tell you flow sensor cal, okay. So let's try it again. We're turning it. And if you watch your waveforms here, you can actually see it changes the flow and the volumes being delivered, so it can sense those and make sure they're being measured correctly. So now it says turn flow sensor, turn it back.
This faucet, this vent used frequently.
What?
Is it still?
Mercy uses it, yes. Okay, now see it says flow sensor calibrated okay. And then if you don't pay attention, you'll miss it like I did because it says it quickly and then it goes away. You need to see that it says flow sensor cal okay to know that you need to go on. If you don't see it, you need to do it again. Okay, so that's good. So we know that's done. Now we're going to go to the tightness test. All the tightness test is a leak test. It's going to test the integrity of the circuit to make sure there's no leaks in it. So it's just what it's called. So you go to there, push it, tightness test. Now it says tighten patient system. What that means is go like this. Close it off. Once you do that, it knows you did it. Pay attention to the blue, tighten patient system. It's actually running the test now. It says patient system tight. Now it's trying to deliver a breath. So if you get to this point where it's just automatically cycling, what it thinks is happening is my ET tube is occluded because my hand's over it. So that's why it's just dumping. And you can see what happens when we hit a high pressure alarm. Look, there's no volume, nothing being delivered. It's just going up and just stopping, going up and stopping. So that's a good example of what happens when you get a high pressure alarm. No ventilation is actually happening on this patient if this is a blocked ET tube right now. So, huh? All right. This ventilator is used at all the Mercy hospitals. They actually have a new one. It's called,
I thought Mercy someone used the Draeger.
everyone but that one uses the Galileo.
Galileo's a good one. So.
Actually, this is an okay vent. It just drives me crazy that it's not touchscreen. So there's actually a new vent out that's called the G5. That's just like this. Eventually this will go away.
Fly like a G5.
It's touchscreen. Yeah, it's touchscreen. It's actually really, really nice. But so if you guys come across that someplace that has it, don't be intimidated. Number one, because when you learn one vent, you can do them all, right? Number two, don't be intimidated because it's exactly like this. It's just touchscreen now, so it looks the same. It looks prettier, but you can actually do touchscreen with it. So, so on the right-hand side, you guys, is where we do our patient parameters. In the middle are our waveforms. Here we get some patient parameters, but if we go to the other side and touch the paper, then we get all of our patient parameters, the in-depth ones, because there's only a handful over there. Over here, we'll do all of our set parameters. So remember, our different sections, we just need to find them on this vent. So we have a couple that we can control right from here just by going down. We see orange, touch it and change it and then confirm it. If you want to change those, you can do them right from here. Otherwise, to change mode and more in-depth settings, you have to actually go into mode. Okay. So here, remember I was telling you today, SCMV is what?
AC.
AC what? ACVC. PCMV is what? ACPC. SIMV is SIMV volume control. SIMV is SIMV pressure control. P in the front for pressure. So remember, every vent's got to call it something different, so that's what this one's. Don't worry about, and then APV is PRVC on this ventilator.
APV.
Yeah,
What does it stand for?
adaptive pressure ventilation. So, and then don't worry about the DuoPAP, APRV, those yet, because we're not doing that right now. So there was our calibration. Additions, don't worry about. I will tell you that this ventilator has TRC, which is tubing compliance. It's what it does is it adjusts for the actual ET tube. So you know when I talked about pressure support earlier, I told you there's no way to know exactly how much we need to compensate for. If you go here, it's going to say, do we have an ET tube or a trach tube or disable? We'll say, let's say we have an ET tube. We can tell the ventilator that my patient has a size 8 ET tube, and I want you to compensate for 50% of the resistance. You could have it compensate for 100%, 75%, 50%, 25%, whatever you want. But that will give a precise amount of similar to pressure support to give the exact amount of help that's needed to overcome the resistance from the ET tube. They've calculated that if a patient has a size 8 ET tube, this is exactly how much assistance that patient needs to overcome the resistance of it were they not intubated. So this is very, very precise. Some people use this in weaning to put them in the TRC, and then strictly the patient would be breathing on their own because we would only be giving them enough support to compensate for that.
The tubing compliance thing that's talking on the book, that's volume, right?
Tubing compliance?
Yes, you know how it calculates how much is lost on the circuit? or
That's
something?
different.
That's different.
Yeah, this has to do with the ET tube specifically and how much extra support we need to give our patient to compensate for the resistance from trying to breathe through a straw instead of not a straw. The compressible volume or compliance, or tubing compliance, has to do with the circuit. So don't confuse the two, they're different.
That's the same, they have that on the PB too, the TC.
Yes, TC. Yep, it's tube compensation. So the C stands for compensation. And so we're going to disable it and then confirm. Okay, so the other thing from the mode that you can do is put it into standby, which is right here. Standby, orange, hit confirm. This is not in standby yet. You actually have to take it, and this is the time you're going to have to use the blue. Activate standby, confirm, now it's actually activated. Until you do that, it's not actually in standby. So, and it'll tell you how long it's been in standby. So once okay, so now we're done. We want to go back. Patient came back from OR. We're going to resume ventilation, and now you can go back to what you were doing. Controls is where we can set more complicated. You'll notice in this ventilator, in assist control, we do not have an apnea backup. Because the logic to that is we're in assist control, we don't need an apnea backup, which technically you don't. But the ventilator is going to breathe for the patient. You'll see if you go to SIMV, though, there is an apnea backup there. So that's why you're going to see it, and sometimes you won't. So here for our flow pattern, there's a couple here that look the same. Come back. This is the ramp. That's the one we don't use. That's kind of like a ramp, but not exactly. So you should have it set on this one. That looks like the one we talked about today. That's where we can set our I to E ratio. This ventilator, you set the I to E ratio. You do not set an I time. Obviously, you set the I time indirectly, but a lot of them have an actual I time. This one just has the ratio. Rate, tidal volume, PEEP, FiO2. Here's our sensitivity. This is in pressure trigger right now. It's positive. It's negative. It's at -2. Flow trigger is at positive or negative numbers?
Positive.
Positive. So if you want to change this one, see this little dot right here? You could put the orange, so the orange is at the dot. Watch what happens. Trigger off, flow trigger. And then we can go down to it and set it. So we'll just put it at 3 for now. Typically, though, the vents will auto-cycle if we don't have this way up. So for now, I'm just going to put it up. And then we do close, and we'll just ventilate. On here is our waveforms like we started talking about today, so you guys can really pay attention to these. Here's our volume, our flow, and our pressure. And then if we go to, I'm going to go to SIMV so I can show you. So we go to SIMV, then another screen comes up. If you do not confirm this, it won't actually change to SIMV, so just like all the ventilators, changing mode requires extra confirmation to really confirm that you want it to be done. So we're in SIMV now. Look, we have more additions too that we didn't have before because there's a lot more to set. So we have our apnea backup, so we can set that so the ventilator will kick in. Remember, 20 default for the actual time. Other than that, you can set your tidal volume and those the same as what you're delivering. Then we have our inspiratory time, pause, P ramp. That is like inspiratory rise time. What I was telling you guys today on the ventilator is called P ramp. So how quick am I going to get to the pressure? Expiratory tube sensitivity. That's for the pressure support breath. How does it know to cycle off? Flow trigger, and then pressure support, because now we're in SIMV, so we can add pressure support. The expiratory tube sensitivity on this one defaults to 25. Just leave it there. That's where it should be, unless you have another kind of patient. But we're not going to worry about that for now. And then alarms, where we can set our alarms. The alarm screen is kind of a pain. So watch your orange. See, there's my orange. That's where I'm at right now. So I push it, and then I can change it. And then you keep going. So now we're at air trapping, which we don't use. You could actually set it to watch for air trapping. Auto, if you wanted to have the ventilator, just pick the alarms, but it will automatically default to these here, and then you can go in and change them. And tomorrow we'll talk about alarms, but tidal volume 200 below, 200 above. Rate is going to be 10 above the average respiratory rate. Pressure, high pressure 10 above, but no more than 35. So if your high pressure is 20, you'd set your high pressure alarm at 30, 10 above the average. Remember that these are not going to be set the same every single breath. But if your pressure is averaging 30, you would go to 35. So we go 10 above, but no more than 35. And don't automatically go to 35. Sometimes people think, oh, I can just go to 35 no matter what my peak pressure is. If your peak pressure is 10, you don't want a high peak pressure of 35. It would be 20. And then low pressure is going to be 5 to 10 below. 5 to 10 below our average pressure, and then minute ventilation, 2.0 liters above the average minute ventilation, 2.0 liters below the average minute ventilation. And then we can close. And then if we go over here, we can get all of our patient data for our vent check and our checks to make sure that everything is where we want it to be.
$42,000.
This has got a lot of miles on it.
Freeway miles.
Yeah.
Freeway miles.
So here you will have, here's your resistance and compliance. Here for you, we have inspiratory and expiratory resistance. We use inspiratory. And remember your units of measure too. And then here's where your flow is, your I time, your E time, your peak pressures, all of that. This ventilator, when you try to do the inspiratory pause, this one, you can go in and see your other kind of graphics if you wanted to, like your flow volume loops and all of that is where you get that from. Next, the little snowflake freezes the screen. Like freezing snow, yeah. It's cute. So now we're going to unfreeze it and just let it keep doing its thing. Lungs, do some maneuvers that we're not going to worry about. And then that's the event log. We'll tell you all the alarms that have gone off. And then this down here tells you the most recent ones, the little iPad. And then there's one.
I think it's the hand.
Yeah.
For inspiratory pulse.
That's what I'm looking for. Thank you.
And
Yes,
Yeah.
it is. I never use it because it doesn't ever work. So if you go over to there, it doesn't. I'm going to show you a different way to do it. But everyone sees this, so they ask me about it. If you do inspiratory hold and expiratory hold here, so let's do an inspiratory hold. So we do our hold, and then we go.
you gotta go to the information thing.
I know, I'm trying. Thank you, though. You will see that it never registers a plateau pressure when you do that. I've never been able to do it. So what we do is go over here to controls, put an inspiratory pause on of about 5 or 10%, close it, and then watch your breath. You'll get a little bit of a pause. And then you can go to your little paper and you'll get your plateau reading. But then you got to make sure that you go back and turn your plateau off.
This one's complicated.
Then you'll probably get it for the midterm. Just kidding. Wait till you see the Draeger. No. So, questions?
Tell them about the button for the inline treatment. The one on the right.
We don't use it.
I used it yesterday. That was cool.
Yeah, there is a way to do a nebulizer inline, but most places don't use it. It's right there, and then you push the button right here to start it. 100% O2 breaths are down here. We can do, the nebulizer's running now. But no one does it that way, but it is there. Okay, you did. Okay, so one person does it that way.
Yeah, David.
Get him, David.
The O2 breath right there when you suction the
Yes. When you suction, this is where you're going to do, what you're going to do right here. So, all right, so the last half hour, let's get the vents. I got the lab for you. Let's go ahead and start getting everything set up, and I'll go get your lab.